What is the first derivative test? The first derivative test is a method for determining whether a critical number is a minimum point, maximum point, or neither. Prior knowledge. What are critical numbers? Critical numbers are x values at which f of x exists, but f prime of x is either 0 or undefined. In other words, critical numbers are x values where a function f of x has a slope either 0 or undefined. How do you find the critical numbers of a function? When a graph is presented, you look at the x value at which the slope is either 0 or undefined. What an undefined slope would look like, at the x value there would be a sharp turn, hole, break, vertical tangent, or vertical asymptote. The x values at the purple points show a 0 slope. Therefore, these are the critical numbers. To find the critical numbers when a function is presented, you first take the derivative of the function. A critical number is the x value when the derivative of a function is 0 or undefined. In this case, the derivative is never undefined, so you would then set the derivative equal to 0 and solve for f. In the end, the critical numbers of this function are x equals 2 and x equals negative 2. What are critical numbers used for? Critical numbers are used in the first derivative test to determine for local minimum and maximum and global minimum and maximum. Why does the first derivative test exist? The first derivative test exists to determine whether a critical number is a maximum point, minimum point, or neither. Common mistakes. Don't forget. Don't forget about domain restrictions. Those values cannot be critical numbers. Domain restrictions are discontinuities. Also, watch out for monotonic functions. Relative maximum and relative minimum do not exist with every critical number determined. Even though the slope of a function is 0 or undefined, the function could be strictly increasing or decreasing. Also, don't forget about a given interval. How do you use the first derivative test? When asked to find local extremas of a given function, you find the critical numbers to use in the first derivative test. First off, there is a domain restriction. X cannot be 0. Then, to find the derivative of this function, you need to use the quotient rule. Once you get the derivative of the function, find the x values where the derivative is both equal to 0 and is undefined. In this case, the derivative is a fraction. This means that the derivative will be undefined when the denominator is equal to 0. So basically, 0 is not in the domain, so it is not a critical number. The derivative will equal to 0 when the numerator is equal to 0. The x values that you solved for excluding 0 are critical numbers. Now use the first derivative test to determine whether a critical number is a relative minimum, relative maximum, or neither. So you have to substitute a number greater or less than each critical number into the derivative and solve it out to see whether the answer is positive or negative. In this case, negative rad 2 over 2 is a relative maximum, and rad 2 over 2 is a relative minimum. 0 is not a critical number as shown by the dashed line, which represents a vertical asymptote. When asked to find local extremas, you need to find the critical numbers and use the first derivative test. First off, for this given function, there is no domain restriction. To find the derivative of this function, you need to use the power rule. Once you get the derivative of the function, find the x values where the derivative is equal to 0 and is undefined. In this case, the derivative of this function is never undefined. So then you move on to find the x value, where the derivative is equal to 0. The x values that you solved for are critical numbers. Now, use the first derivative test to determine whether a critical number is a relative minimum, relative maximum, or neither. So you have to substitute a number greater or less than each critical number into the derivative and solve it out to see whether the answer is positive or negative. The function is monotonic because it is always increasing from negative infinity to positive infinity. Not every critical number produces a relative minimum or maximum. To find the critical number of this function, we are going to graph it. The negative sign on the side of the absolute value means you reflect across the x-axis. The plus 1 means you shift 1 unit to the left. For the 2x, the 2 is greater than 1. This means that there will be a horizontal squeeze. Now that we have graphed the function, we can see that there is a sharp turn at x equals negative 0.5, which means that the slope is undefined at this point. So x equals negative 0.5 is a critical number. Now use the first derivative test to determine whether a critical number is a relative minimum, relative maximum, or neither. Based on the graph we just did, the slope to the left of negative 0.5 is positive, and the slope to the right of negative 0.5 is negative. As a result, we know that negative 0.5 is a relative maximum.